what is a tree diagram? In the context of probability, a tree diagram is just a graphical or pictorial representation of outcomes and probabilities. I'll give you an example, or rather, let's just explore how a tree looks like. So a tree starts like, it looks like this. These are called branches. So we have branch 1, branch 2. This is the starting point, okay? And then here is the decision making point, okay? So at this point, you can make a decision and you can make another decision. Even here, you can make a decision, you can make another decision. So here at the end, you have outcomes. Outcome. By the way, it's not outcomes, it's outcome. One thing to note is that the outcome, this outcome, and this outcome, and this outcome, and this outcome, when you add them, they must give you 1. Or the sum of outcome A, B, C, D is 1. Okay, outcome number 1 is this one. Outcome number 2 is this one. Outcome number 3 is this one. Outcome number 4 starts from here is this one. One other thing to note is that the events are independent. The events between the branches or between the outcomes are independent of one another. The event between the outcomes are independent of one another. What does that mean? The outcome of B1 is independent of the outcome of B2. Now, let me give you an example to solidify the understanding. So, if you have a bucket, right, and then you have balls in this bucket, you have 2 blue balls or marbles, whichever you might want to use, and then you have 3 red. Balls, okay? And then you're asked to randomly, this is you here, you're asked to randomly select a ball from this, randomly, without looking. You select and not replace. What does that mean? When you take out a ball, you don't take it back. All right, so you do not replace back into the bin. Okay, so if we have to draw the events to understand the probabilities here, we will look, if we have to draw the tree diagram to understand the events and their probabilities, it will look like this. So you have 2 choices to make here. You have blue balls and red balls. So you're going to have blue and red. And red. At first, you have 3 red out of total of 5. And then you have 2 out of 5. When you add 2 over 5 and 3 over 5, you will get 1. So this is the first. Now, before you draw the first time, this is how the probabilities look like. So here, you draw a ball. This is a decision making point. You draw a ball. You don't know what it is. So here, if the first ball you drew is blue, then the probabilities will look like this now. Remember, you still have blue, you still have blue, you still have red. If the first ball that you take out is blue, then we're going to have 1/4. So our blue will no longer be 2, will be 1. And then our red is not affected. That's why we say the events are independent. Then for the reds, we're still going to have how many? We're still going to have 3/4. The same applies here. If the first ball you took out is red, then the blue will not be affected. We're still going to have 2/4. And then the red will decrement. In other words, reduce by 1. So the red will be 2/4. When you add 2/4 and 2/4, you're going to get 1. If you add 1/4 and 3/4, you're going to get 1. So the outcomes will look like this. 2/5 multiplied by 1/4 represents outcome number 1. Here we're going to have 2/5 multiplied by 3/4. Outcome number 2. And we'll have 3/5 times 2/4, which will represent outcome number 3. And we'll have 3/5 times 2/4, which will represent outcome number 4. So in actual fact, all of these outcomes will add up to 1. So in short, this is what it looks like. This is what so the question may arise that what is the probability that the person will select the first, what is the probability that the first ball the person takes out is blue and the second ball is red? For example, in the first draw you take out blue, and the second draw you take out red, in that order. In other words, we want blue and red, not the red and blue. Okay, so the first one must be blue and red. So if you want to understand that probability, we will take this one. Our answer is already there. Our answer will be this one. The first one is blue, then red, so it's going to be this one. 3/2 is going to be 6. 4/5 is 20. So this is our answer. So mathematically, you will write it like probability that the first ball is blue and second ball, probability of blue and red is equal to 6/20. It's going to be 6/20. And the question may arise again that what is the probability that a person will select balls that are the same? In other words, in the first draw you select a blue, in the second draw you select blue again, or in the first draw you select blue, in the second one you select a red. So we have two possible events where like the probabilities will be the same, or when the balls that are drawn out will be the same. That is blue and red. So you're gonna say probability of blue plus probability of red is equal to, let's understand blue, it will be this one and this one, and it will be this. It will look like 2. 5/4 is 20, so it's going to be 2/20. And then red and red will be 3 by 2 is going to be 6. 5 by 4 is going to be 20. So we'll have 2 over 20 plus 6 over 20. So we'll have 2 over 20 plus 6 over 20, which will give us 8 over 20, which will give us 4 in here is 2, 4 in here, it's going to go 5 times. So this is the probability. In other words, 2 out of 5 times you select balls that are the same. So in other words, you select on 2 draws, you're going to draw out balls that are like blue, and then you're going to draw blue again, or you're going to draw red and red again. This is going to happen 2 out of 5 times. Okay, and then here, if you want to simplify this part here, you can have 2 going in here is 3 over 10. Okay, so in simple terms, this is what tree diagrams are. Please let me know if you want more videos on tree diagrams, on probability questions, or on function questions, or rather function examples, and or rather if you didn't understand the functions or anywhere I was explaining, just let me know. I will make a video on it. Cheers.